Hi, welcome to another video, and this video is going to be all about modules. So what is a module? Well, if you've done any programming in any other language, PHP, C++, you would have come across classes. These classes is a cluster of function, a class of functions, just loads of functions put together in one file. Well, these are same with Lua modules. It's called modules instead of classes. If you have a look at how many modules there are in the modules directory in Mach 4, you can see just how cluttered your screen load script would become if you piled all of that into there. So it can be made a lot tidier and a lot simpler by creating modules. Now, a module normally does a specific purpose. This is the master module, so it's holding a lot of the functions that Mach 4 will look for when it's getting registers, setting registers and saving registers, etc, etc. So before I go ahead and show you how to create your own custom module, I'm going to show you first how to load a module. From Mach 4, if you go into the editor and then the screen load script, you'll find this little section here. Now, in Lua, your modules are loaded into a table in Lua called a package table. Now, first off with Lua, you must tell Lua where this package path is. This is the path it's going to look for your Lua module. Now, it doesn't only have to be one path. You can put a search criteria in here and it will look in each one of these directories for your module. This path here is looking in your Mach 4 profiles modules directory, so it's specifically looking in a profile. And then the last one here is looking in the Mach 4 modules directory. Once you've loaded a module, it stays within this table, does not change. If you do the require master module and the master module is already loaded, it will skip that require. So if you've made some changes in your master module, it will not get loaded again. So what we need to do is add in this little package.loaded master module equals nil. Is what that'll do is unload it from the package table, which then when it comes across to the next require master module, it won't find it in the package table, so it will reload it again. Great, so now we know how to load a module and unload it with the nil command. Let's go and create our own module and put some custom functions in it. If you go into your operator and edit debug scripts, don't worry about putting anything in, just put a load of rubbish in there and click open. The Lua editor will not find it, so it'll give you an error, but it's opened up your Lua editor. You can then go save as, go into your Mach 4 hobby directory, into your modules, and then give this a name that you'll remember that is your module. Well, it's going to be custom functions for me, so I'm going to put cust func, just abbreviate it, then give it the extension of Lua and save it. You've now got a file within your modules directory called custfunc.lua. Right, so in our module, the first thing we need to do is declare our table of functions or class of functions. So we'll declare that as local, and what was we called? It was called custom func, so we'll just abbreviate it like that. And we need to tell it that is a table, which is done simply like that. To close off a table, or to tell it it's a module, close off a module, whichever way you want to put it, whatever it does in there, you want to tell it to return whatever the custom function has done, and it's as simple as that. That's the start and end of a function, of a module, sorry. That is how all of them are done. So obviously we're in Mach 4, so one of the biggest things we need to put in here is our instance. Which is like so. Now in the master module, you'll see there was functions in there for get register, set register, save registers. Well, you can have functions for anything. Well, this is your own custom functions, so you could move those registers over to here. Even though they're already declared within the master module, you can still declare them in here and keep all the commands you use in one spot. Now, something that's used a lot in Mach 4 is signals, input signals, output signals, control signals. So all the time we're using a command to get the handle of this signal, so then we can get the state of that signal. So I'm going to do two custom functions in here to start off with, which will be to get the state of a signal and set a state of a signal. So to start with, two functions that seem pretty straightforward to me, or something that will be required a lot, is to get a signal state and to set a signal state. So let's do a couple of functions. So the first function, we're going to get the signal state. Now within a module, to show that it is, we can't just do get sig state. Oops, we can't even do that. We can't just do get sig state. We need to tell it is part of a module, and we do this by putting the module name in front of the function itself, because custom func is a table, and then within that table we're going to put in a function of get sig state. So you'll find they all start like that. Now, what are we getting the state of? We're getting the state of a signal. So from anywhere else in Mach 4, we need to pass the signal across to that function. And of course, the function we end. Next function was function, again, our custom func, and we're gonna set our sig state. What is up with my T? There. Now, within this function, yes, we've got to send it what signal we want the state of, or signal we're going to set the state of, and then obviously we've got to pass it the state of what we want that signal to be. Ta-da. So that's two functions. let's fill up our GetSig, and the first thing we're going to want to do to get the state of a signal is to get the handle of the signal. So let's declare another variable equals MC, and it's a signal command which won't pick it up because I made a boo-boo. So you should get it now. MC signal get handle. Of course we need to pass it the instance, which we've already declared as inst, and we need to pass it the signal ID of what we want. So we've passed from Mach 4, we've passed to this function sig. So that's what we're going to look for, is sig. So now we've got a handle to our signal, we need to get the state of it, which once again we can just use a straightforward state, and that is equal to mc.mc signal command, which will bring up these, which we've got to get state there. As you can see, all we need is the signal handle to get the state of that. So we can just pop in hsig. Great, so we've got the state of our signal. What do we do with it now? Well, we need to return it to whoever asked for it. So we return it, and we tell it what we're going to return, which is going to be the state. That function's complete, that's done, that's all it needs. So let's now do exactly the same with the set register. Now obviously we need to get the handle for the signal, so we can copy and paste that, which is going to be exactly the same. Now this one's going to be basically the same underneath as well, apart from we don't need to declare anything to it at the moment. So we can do an mc.mc signal, and we can set the state. So we can set the state of that. We've got our hsig again, which we've already got, and then we can set it to the state of what we've told it to be. That's another one, that's complete. Now we don't need to return anything in here. It's always wise to put some error check in, etc. But that's going to come in another part. That'll be an advanced modules one. This is just straightforward, simple, get you going stuff. So before we move any further and load this into Mach 4, let's just do a quick check if everything's okay. So if we press F5, nothing will happen. I don't know why, because I'm not highlighted. Right, if we press F5, we'll now go into the debug mode of the editor, and you can skip using your F11 all the way through, which will just go and check the basic syntax of it. It won't go into the MC signal get handle, etc., because it's a function. It will only declare the functions and check them. We know that's okay, so let's go into our file and save, and then come out of our editor. So we've got a module called custfunc, and we need to load this into Mach 4. So let's go into our screen editor, highlight the top of your tree, which we can then find our screen load script, and we'll go to the module section. We'll keep it all together, which is here. So what have we got? Let's this is going to be our custfunc module. Again, we need to unload it in case it's already loaded. So we'll tell the package table, and what are we called again? Custfunc, and we'll tell it that that equals nil. Now loading our module, we've called it custfunc. Now we do not have to call it custfunc or anything. If you notice with all the other packages, they're abbreviated. This makes it simple for you to type, quicker for you to type, but you can call it what you like. I'm going to call it CF, just short for custom function. And the custom function CF is going to be our module, which was custfunc. No need to put the .lua on the end of it, because we've already told that within our package path to look for .lua files. And well, that's it. That should now load our custfunc module. And there's no errors. So we've now got our custom function module running within Mac 4. So let's now test out our new function. We'll go back into the screen editor, and I'll use one of the dummy buttons which are here. You've got one at the top and you've actually got one at the bottom here. So I'm going to go into the left up script of this one, and I'm going to get, let's say, get the state of input 1. So let's declare a variable of state, and that is going to be equal to the value we get from our CF get sig state. So now we need to pass the signal to that function that we wanted, which is going to be our input 1. Where we want there. And that's it. And we'll use a good old message box to output the result from it, which is going to be a number, integer. So we need to change that to string, as the message box requires strings, which is going to be our state, and close it off. So let's hit F5 to go to debug mode, and then F11 to skip through it. Now you'll notice now we've got an error. It can't access CF, which is our module. When in debug mode, debugging buttons, panels, anything, it tends to be in a local environment, but there is a way of debugging, and it is a lot better to do it this way, because you'll be debugging your module at the same time. Now, what we need to do is come out of here, save it obviously, go back into your screen load script. Now, what we need to get this working is a part of our screen load script, which is our package.loaded custom func, and obviously the package path. We need those to get things going again. So back in our button, we'll go back to the left up script, and we're going to put all of that in the top here, and it's purely for debugging purposes. So that will become that. We need our instance, the directory path for it to search for, and of course the CF require. Now, as what this will do, when we now go into debug mode by pressing F5, it will load our package into the debugger. If we click open here, you'll notice it's now debugging our module. So now we'll get to the local state equals CF get sig. So if we press F11, it's now gone to our custom function get sig state, and it will actually run what is happening in our module. Bring us back to the message box, which is now brought us a message box here, and we can see that the state of our signal is 0. It's great, isn't it? So let's go one step further. Let's set the state to 1, which is going to be CF dot set sig state. It's like that. Obviously, we needed to tell it the signal that we're going to set the state of, and also what do we want to set it at. Obviously 1 is going to be on, or you can do the mc.on, true, and bits and pieces like that. So if we set the state and now press F5 and run this again, we can now skip through the functions with F11 again. When it gets to here, it's gonna unload the custom function and reload it just in case we've made any changes in it. So there's our function reloaded. CF set sig state, we've gone to the set signal state. It's got the handle and it's set the state. Nothing to return, so it's fine. Local state, we're going to get the state of that input 1 that we just did. So go through the same thing and it will return the state and give us the message box, which should be what we've just set it to, which is 1. So our input signal is now on. So just for the sake of me, because it is connected to my machine, although the power's not on, I'm just going to flick that back over, and in fact I don't need to do that. I can just do run. So my signal's back on 0. Great. So that's our first thing. When you're debugging, you will need those to reload your package, your module within where you're debugging. So when we're not debugging, we don't need all this part at the top. We don't need that, so let's get rid of that. Now we can close this off, or hide it from the script if you like, by doing an open statement like that, and then a close statement, which will then just turn that into, well, nothing basically. It won't be there. If we come out of the Lua editor, quit out the screen editor, this will now be running from the screen load script. So if we enable, you'll see that our command from our module is working, and we don't need all that stuff. Next time you want to edit anything from there, you go to the button. If you're going to do any debugging, you can just take these back off, and then you can run it in debug mode. So we've now got our custom module working throughout our Mach 4 GUI. One extra little piece we need to do now. As it stands, it will not run in a macro. There's a small addition you need to make. If we go to the operator and edit debug scripts, you'll find a new script now in your macros folder called load modules. This is an addition to 3390. If we open this module up, you'll find it's already loading some of the modules. This one is loading the error check. So if you want to load or use your modules within your macros when running G-code, then you're going to need to load your module in this file as well, so it gets compiled at runtime when Mach 4 starts up. So underneath the error check module, let's add our custom function module, and quit and save what we've changed. So debugging macros is a slightly different way of doing things. If we go to edit a macro, I've got an M101 set up here. This is our Bob basic layout for a macro in Mach 4. Now, once again, if I was to go and put the command in here of we want to set the state, cf set sig state of mc dot isig input 1 and set that to a value of 1. If I was to run in debug mode, again you'd find we've now got an error. It's not loading up the custom module. Now there's a different way we can do it in our macro. Now one thing we want to do is within our macros, it's loading other stuff as well. You notice there was a command in there for the error check. So let's get the state of our macro exactly how it would be if G-code was running. Now we can do that in Mach 4 or Lua with a command called do file. Is what this is going to do, it will load our load modules.mcs and run that within our macro. So the environment of our macro will be exactly how it would be as if you was running the MDI or running some G-code. So if I'd done an F5 now to start off the debugger, go through the F11, you'll notice when it gets to the do file, it wants to load the load modules. It will go through, set everything up. There is a lot of F11s to do when you're going through stuff like this. But you get there eventually. So we're now in a state of exactly how it would be if G-code was running our MDI. So now we can do our set sig, which goes across. And as you notice across there in the background on the input signals, it has now turned on our input number 1. So we now know our macro will work perfect. And everything's finished. Debug section is finished and everything, so okay. Now if you want to do it a quicker way, if you're just changing one thing and you just want to see if it brings an error back, you can physically just do a run and it will go through the whole script. Something missing in this editor, which will be an absolute fantastic addition, is if it had the run 2 on it, where you could toggle where a breakpoint on it. But I can't seem to find anything in this editor that will do it, so we could have just run up to that point of where we need it. But anyway, that's a bit off topic, that one. But so we know that is now going to work. That's worked in a debug environment. Now we don't need that when we're not debugging, so we can save. Let's cancel that a minute. I need to change that to number 1 just for the demo so it turns a signal on. Let's save what we've got in there. It brings us to our Mac 4 screen again, and I'm going to load up the good old Roadrunner. And within this Roadrunner I've stuck one of our MO101s in there just to show this will turn on our input number 1 whilst running the G code. And of course I put it the longest place you could waste some video time in it. That's now gone past our 101. Our input 1 has now come on. So we know our module is working, is being called from the macro. And basically everything is fine. Well, that is the basic way of how to set up a module, use it. Same commands within your GUI and within your macros, and it is exactly the same way as you would do it if you was creating a wizard. You could also call that module from a wizard. You can call it from a Lua panel, as long as you've got a way of loading it. Those functions will be right once, but you can use it as many times as you like in different places. So there you have your basic steps of creating and loading modules in Mac 4, whether it's the GUI or G-code. Well, I hope you enjoyed the video, and I look forward to seeing you in the next one.